Today we are covering encoder versus decoder. BERT, GPT, and T5 through the transformer lens. The goal is not to memorize a slogan. The goal is to build an interview-ready explanation that moves from intuition, to mechanics, to trade-offs, and then to a concrete example. Intuition. Encoders read input with bidirectional context. Decoders generate output with causal masking. Encoder-decoder models combine both for sequence-to-sequence tasks. If you remember only one thing, remember the shape of the problem. Raw information is transformed into a representation that makes the next decision easier. Core mechanics. Encoder blocks use self-attention over the full input. Decoder blocks use masked self-attention so generation cannot peek ahead. Encoder-decoder models add cross-attention from decoder to encoder outputs. BERT is encoder style, GPT is decoder style, T5 uses encoder-decoder architecture. Choice follows the task: understand, generate, or transform. The compact mental model is: encoder, read all input; decoder, generate left to right, seek to seek, read then write. Do not rush past the symbols. In an interview, define each part in plain language before you talk about implementation. That makes you sound like you understand the system, not like you only memorize notation. Common traps. Do not call every transformer GPT. GPT is decoder only. Causal masking is the key decoder constraint. BERT is strong for understanding tasks but not naturally autoregressive. Seek to seek models are useful for translation and summarization. Concrete example. For sentiment classification, an encoder can read the whole review at once. For chat completion, a decoder predicts the next token from previous tokens. For translation, an encoder reads the source and a decoder writes the target. Walk through the example slowly. Say what changes at each step, what stays fixed, and why the operation helps the model produce a better representation. Interview checklist. Classify BERT, GPT, and T5. Explain bidirectional versus causal context. Mention cross-attention. Tie architecture to task. Use examples, classification, chat, translation. A strong final answer for encoder versus decoder should have 4 beats. First, give the intuition. Second, name the components. Third, describe the formula or data flow. Fourth, mention the trade-off. If you can add one example, you will usually sound much more practical than someone who only gives a textbook definition. Now let us rehearse the answer in a more conversational way. Start broad. What problem are we solving, and why did this idea become useful in modern AI systems? Then narrow down, what data structure or tensor is being manipulated? Then explain the operation, what is multiplied, normalized, added, masked, or learned. Finally, connect it to behavior: faster training, better context, more stable gradients, lower memory cost, or clearer generalization. For interview practice, avoid 3 mistakes. Do not give only math without intuition. Do not give only intuition without naming the mechanism. And do not pretend there is no trade-off. Most AI interview questions are really trade-off questions wearing a concept label. The best answer shows you know when the method works, when it becomes expensive, and how engineers usually manage that cost. Quick recap: encoder versus decoder. BERT, GPT, and T5 through the transformer lens. Use the mental model, define the pieces, give the example, and close with the practical trade-off. That is the answer structure to keep in your head. One more interview rehearsal. Explain it as if teaching a teammate. Define the input, describe the transformation, name the output, and close with why the design choice matters in real systems. This habit turns a memorized answer into a practical engineering answer.